In the grand cosmic theater of Saturn, most eyes are drawn to the dramatic. Its shimmering rings, its massive storms, its multitude of moons. But behind that spectacle lies a force just as powerful, yet invisible to the naked eye: Saturn's magnetic field. And once again, it was Cassini that gave us our first real glimpse into this unseen realm. Unlike Earth, whose magnetic field is tilted in relation to its rotation axis, Saturn's magnetic field is nearly perfectly aligned with its spin. This strange symmetry baffled scientists. Every known theory of how magnetic fields are generated, called dynamo theory, suggested there should be at least some degree of tilt. But Saturn defied the rules. This was more than a curiosity. The tilt of a magnetic field helps scientists determine how fast a planet rotates. On Earth, it's straightforward. On Jupiter, it's measurable. But Saturn? The near-perfect alignment made it nearly impossible to determine the true length of a Saturnian day. Cassini's data helped refine this mystery. It showed that Saturn's rotation rate may not be fixed, but rather fluctuates over time, possibly due to interactions between the planet's atmosphere, rings and magnetosphere. In other words, Saturn's day might be fluid, dynamic, and unlike anything we've seen before. Beyond its unique alignment, Saturn's magnetic field plays a crucial role in shaping its environment. It forms a vast comet-shaped magnetosphere, a region dominated by the planet's magnetic influence, stretching millions of kilometers into space. Within this bubble, charged particles are trapped, funneled, and accelerated along invisible lines of force. Cassini dove deep into this region, recording not just the structure of the magnetic field, but also the behaviors of the particles within it. It discovered magnetic reconnection events, where field lines snapped and reconnected, releasing bursts of energy. It observed auroras dancing near the poles, otherworldly light shows triggered by solar winds slamming into the magnetic bubble. Most intriguingly, Cassini detected that Saturn's rings themselves were electrically active. They interacted with the magnetic field, producing radio emissions and even altering the structure of the field itself. This meant that Saturn's rings weren't just passive. They were actively participating in the planet's electromagnetic life. Even more stunning, Cassini discovered that Enceladus's geysers were feeding material into the magnetosphere, creating a plasma torus, a donut-shaped region of charged particles encircling the planet. This linked the moon, the rings, and the magnetic field into one interconnected system. The dynamics of Saturn were no longer about isolated features, but a living, breathing network of interactions. And all of this happened far beyond what was once thought possible. When Cassini plunged between Saturn and its rings during its grand finale, it passed through the innermost region of the magnetosphere, providing measurements never before captured. It mapped magnetic anomalies, pinpointed field strength variations, and gave us an intimate portrait of a planetary magnetic system at work. What Cassini found wasn't just a magnetic field. It was a window into the planet's soul. Generated deep within Saturn's metallic hydrogen core, this field may hold the keys to understanding not just Saturn, but all gas giants. It taught us that magnetic fields can be complex, ever-changing, and deeply influential, even in places where traditional models break down. Next on Infinity Beyond, we'll dive into Saturn's legendary ring system, how it formed, what it's made of, and the shocking truth about how long it might last.